Hello, everybody. Nick the Tiro here. We've been going through a lot of material in this class concerning assigning variables, if statements. Now, we need to expand that even more. And actually, we need to look back first. Fundamentally, all programming, whatever programming language you may use, is based upon three things, right? First two actually we covered. One is sequence, a series of steps that, step one happens, then step two, then step three. Then the next thing that we covered were branches, where we make a decision and we go in one direction or we go in the other direction. If it's multiple branches, then we can go into a whole series of branches. Now we need to talk about the third part of this triangle: sequence, selection, loops. Now, a lot of times you hear me call iteration. And what a loop does is basically does the same task over and over and over again. One of the, I guess, general rules of thumb in programming is you do not want to repeat code. You don't want to go down the path of copying and pasting from one area of the code to the other. There's always a better way to do something than to copy and paste code. You never want the same code in your program twice. Now, we accomplish that in several ways. The first way we're going to accomplish it is through looping. Again, I call it iteration because every time you go through a loop, it's called an iteration. Now, the biggest, or what I believe is one of the biggest problems that beginner programmers have with loops is they make a lot of assumptions. They assume they know everything about the loop. You don't want to do that. I'm going to do some demonstrations in a little bit of kind of explain to you why you don't want to make any assumptions concerning a loop. The other thing is we don't really necessarily pay attention to what's going on in the loop. So one is we make these big giant assumptions. The other is we don't pay attention to maybe how many times we want the loop to occur. Sometimes that we may want the loop to occur based upon a finite number. This loop needs to occur 5 times. The other time it might be we have to determine how many times we want to go through the loop. We want to avoid what is often referred to as hard coding. Now, what hard coding often means is you know something about what you're working on, right? The word. Let's say you need to loop through a word or iterate through a word. And let's say you know that word is 7 characters long, or we'll say password. You know that password is 8 characters long. So you write a loop and you write or you type 8. You actually put the value of 8 there. That's hard coding because now your program is only going to work for a word or a string that is 8 characters long. What if down the road it becomes 7 characters or becomes 9 characters? So we want to avoid hard coding. Now, let me do some desktop demonstrations. All right, let's do a little desktop demonstration about loops or iteration. I have some very common things that you might see. These are different decks of cards. These are mahjong tiles, a little east, west here. And let's talk about some common mistakes that students will often make about loops or iteration. And we'll iterate and we'll use some examples of iteration. Probably the biggest mistake that people will make is they will often hard code information into their program. For example, if you look here, I have 7 mahjong tiles. So obviously I would write the number 7 in my code. No, you don't want to do that. What you always want to do is in a situation where even if you know the value, find out what the value is anyways and put that as part of your code. And in other videos, I'll do that as a demonstration, but I'm just kind of explaining. So if I write in the program, there's 7 tiles, what happens when I add an 8th tile? What happens when I remove a tile? Okay, then I would have to go in there and change the code. And I don't want to do that. I want to try to make my code as universal as possible. So oftentimes, say we're iterating through a word or something like that, a password, and we're trying to count, we will find the length. If you remember from one of the previous videos, I talked about finding particular lengths. If we don't know the amount, we can make an example using hard coding. For example, it looks like I have 3 ordinary decks of cards. I don't. This deck of card, this one here, doesn't have 52 cards in it. This one has 40. This middle one has 48. and this one has 52. So if I hard coded, oh, look through the deck of 52, it's not going to work for these two decks of cards. And actually, we could run into problems. What happens on this deck of cards when I get to iteration 41? I'm going to get into an error. What about on this one? What if I get to iteration 49? I'm going to get an error. On this deck of cards, which is 52, yeah, it'll work. But so we always want to find out the information about what we're looping on first and program accordingly. Now, let's take a look at this card. Let's do a simple game. I'm going to flip a card and I'm going to keep iterating through the deck until I find a card that is of greater value. All right, very common problem. We see that. We find the greatest value, find less. So we're going to take this deck. It's a 40 card deck. There's no cards missing. It's just a 40 card deck. And I'm going to iterate through the thing. But the first thing I'm going to do is I'm going to find the first card and I'm going to iterate until I find a card greater than that card. So when I flip it, that's interesting. That looks like a king. Okay, I'm familiar with a king there. And I basically start, I'm not familiar with that card. That's kind of interesting. I have to kind of figure out, maybe I have to do some if statements and logics. This is what they call a knight. Ooh, there's another knight. There's a 6. There is a, wow, that's it. I've already made too many assumptions in this deck. Now, first of all, this deck is an Italian playing card deck, right? A couple things about it. It basically it still has 4 suits. The suits are a little bit different. We have cups, swords, clubs, and move these over, coins, all right? So they do have four suits, cups, swords, clubs, and coins. The other thing is the highest non-face card, see if I can find one, the highest non-face card is a 7, right? The Western decks or the American decks go up to 10, then we get into face cards. So that's where we get, so if we have 7 non-face cards plus 3 face cards, that gives us 10 cards, 4 suits, that's where we get into 40. So as we program, we might want to code to first count the decks. We might want to code even to determine if this is a certain deck for a certain game. All right, so let's use this deck of cards. Going to do the same game here, right? I'm going to flip the first card and then I'm going to keep iterating through. You know what? I'm going to change the game a little bit. I'm going to predetermine the card I want. I want to find all cards that are less than 5. And I'll start flipping. Ace, nope. King, nope. King, wait a second here. How can I have 2 kings of spades? Queen of spades? How can I have 2 queens of spades? Jack of spades? Something's wrong here. No, nothing's wrong here. Actually, something's wrong here. Actually, nothing's wrong here. This is a pinochle deck, and a pinochle deck has 48 cards, and if I remember correctly, they only go through 9 through ace. So 9, 10, jack, queen, king, ace, and then they double it. Each suit has 2 sets of cards. So again, we can't make the assumption. We need to know a little bit about what we're iterating through. This deck is, the first thing we'd want to find out is how many cards are in the deck and if there's duplicates and all this other stuff. Finally, we get to a deck that we understand, right? And in this one, it's not a trick deck. I'm not a magician here or anything like that. I want to play my game, and I've done my homework. There's 52 cards in this deck, but I still don't want to hard code that. I want to go through, I want to flip a card, all right? And I want to find any card greater than that. And I'll iterate until I find a card greater than that. That's a little 9. So 9. So let's play the game again. That was a little kind of boring. Flip a card. We want to find all cards greater than 8. Nope. Nope. Yes, there. Right? So we iterated. Did we know exactly how many cards to get through? No. We kept on iterating until we got 10. Let's play it one more time. 7. There we go. Right? So sometimes our iteration, is going to be very quick. Other times we have to go through it. Now, let's look at these mahjong tiles. for a second. East meets west here. These are, I intentionally selected a certain amount of Mahjong tiles for a reason. One, I can count the number of tiles immediately, 7. So one of the first things I would do in my program, I would say, find me the length or find me how many. Remember in a previous video, length is not a measurement of distance. It's a measurement of how many elements. So 1, 2, 3, 4, 5, 6, 7. We have 7 notes. So I can say in a loop, repeat something 7 times. Or what I would really say is repeat based upon the length. Okay. So we find the length, repeat upon the length. And what I want to do here is I want to go through every tile and then do something, maybe sort based upon the given tile. So if I flip this tile, oh, that's a 1. They call that a 1 of ball. Oh, that's a 1 of 10,000s. That is the tile for south. And again, each time I would go through these tiles, I would make some kind of determination on it. And because it's a finite number, the loop can be fairly quick. That's east. That's a 1 bamboo. That's west. And that's north. So every time I went through, I'll do it again. I first measured, or I found the length, and I said, repeat, or for however long it is, this happened to be 7, do something. Flip it, flip it, flip it. And at each time we can, maybe sort this, say, okay, anything that is a non-number, we'll move it up to there. That's a non-number, we'll move it there. That's a number. That's a number. And that's. So we basically sorted them by these are specific numbers and these are direction points on the compass. Now, we haven't started programming yet because I really wanted to get through some really fundamental things associated with loops or iteration. One is don't assume. This is a 40 deck card, 40 card deck. It's different. It's the Italian deck, right? So we would have to write our program accordingly. First thing we'd do, we'd say, okay, find out its length. Again, we can't make assumptions. This is a pinochle deck, and you can see that it's completely, it'd be a wonderful poker deck, wouldn't it? It's a pinochle deck, so we would have to make considerations. Maybe we iterate and say, just find me 5 cards. 1, 2, 3, 4, 5, and stop. And then maybe our partner, we give 5 cards. 1, 2, 3, 4, 5, and we would keep doing that. Right? And then we don't hard code. Here's our standard deck that most people would be familiar with. We don't hard code. We don't say, okay, we're looping through a deck of cards 52 times because what if there's 40 cards or what if there's 48 cards? Okay, we did a couple little desktop examples, but there's a lot of variations with loops. For example, we might loop through, we meet a certain condition. For example, you may not be familiar with this, but you probably used it many times. Loop until you tell it to quit, right? So maybe you're looking at something or searching something, or it's asking you questions, and at a certain point you quit. And that's basically a loop. Maybe you don't know the total iterations. Let's say you're going through War and Peace. You're looking at every word in War and Peace. You might stop, or you would program it to stop at the end of the file. So you hit the very last item, then you stop. So there's a variation, and loops are critical. They're one of our 3 parts of our triangle. We have sequence, selection, and now we have loops or iteration. So they become important because they can tell the program when to stop, or they can tell the program to continue on, or they can go through and do the same task infinite number of times based upon what you're trying to accomplish. If you're looking at cards, or maybe you're going through War and Peace and you're saying, find all the occurrences of the word Minsk in War and Peace, that would all be done through a loop. So that being said, let's learn how to program loops, and let's go learn something. Thank you.